Now we have the basic animation, the initial animation. Now what we have to do is we have to choose the boxes like randomly, and within every box that we select, we have to place this entire initial animation inside it. Okay. So what I'm going to do is I'm going to keep this box scale to be 0.99 and f at p scale is equal to 0.92. So like we need a bit smaller p scale, and we are going to do this for every iteration. After that, for all these points, we are going to keep a point scale 1. So we are starting with the p scale 1, and we are going to create a subnet, and we are going to create a value chance. We'll call it float. Sorry, it is a float value, and we'll call it chance. And we'll call it add detail. So this chance will be like the how many percentage chance is there that every bots will get selected and subdivided and replicated. So first we will assemble these boxes and create packed geometry, and before that we'll multiply the p scale by 0.92. So for each iteration this value will be multiplied so that there is some gap in between the boxes, and we are going to transfer all the attributes. Now we'll use for each primitive, and we'll also need this meta import node. We'll put down a wrangle and we'll call it chance. First we'll access this iteration value and we'll create a random value. Here also we cannot access ptnum because for each and every loop the point number, there's going to be only one point and its value is going to be 0. So I at, we'll call it iter is equal to detail. This iteration is a detail attribute. One iteration, 0th component. And we'll create an if statement. If rand at iter is less than chance, I at group split is equal to 1. So we'll create a group called split. Okay. Now we'll put a split node, and we'll select the split group. Now it's 0, and as we increase it we are going to have more pieces selected. And let's unpack it and transfer all the attributes. And first I'm going to like transform these points, but I want to scale them actually 0.5 times, but we cannot do it directly because the pivot is not in the correct place. So we'll use $gcx, $gcy, $gcz in the pivot, and then scale it by 0.5. Yeah, now it should scale like from the centroid of each of these, and we'll again delete all the primitive, but keep only the points. Let's object merge the initial animation. We'll call it initial, and we'll delete all the unwanted things from here, if any, and copy and paste and copy to points. Okay, but the scale is too big. We'll put down our angle and f at p scale into equals. So we are going to fit 4 boxes, I mean 4 initial animation inside each and every box. Okay, so 0.25. Yes, so this should be fine. Now we'll come out and we'll increase the chance. Okay, first we need to copy parameter and paste relative reference. Yes. Now we can decide like for how many percentage of the pieces we need to add detail. And one more thing is we need to merge the remaining pieces. And we need to unpack these two. For the first iteration, we will choose a value of 1. So we are going to add detail to all the boxes. And if you play, we can already start seeing some interesting patterns. But if you see, it is all oriented in the same direction. So let's do something to fix that. Okay, we'll put down another angle just before the copy to points. And I didn't find a better way to do this. Again, I'm going to create another iter value. We'll just call it it detail 1 iteration 0, and I'm just going to add some seed to it. And let's connect the second input to the metadata. Okay, we'll call this direction. And why I'm creating this is I need to create a random value. We'll see what I mean. I'm going to create a vector called direction, and I'm going to input all possible direction in this. I didn't find a easier way to do this, but this is not that hard. So first x-axis 1 0 0, x is equal to positive 1, and then minus 1 0 0, and then for y 0 1 0, then minus y 0 minus 1 0, then for z 0 0 1 and 0 0 minus 1. So we have all possible directions here. Now we have to choose one of this randomly. Okay, if so we are going to do the same thing we did before. V at n, we are going to assign the direction to the normal. So normal direction is where the boxes will face direction, and we can access any one of this value 0 1 2 3 4 5. So from 0 to 5, any of the value we can access. There is some issue here. Okay, so this is array. We forgot to give, we can declare it as array. Now we can use 0 or 1 or 2 to get the value, and we need to now randomly select this value. So we have I at it, so int we'll call it random value, RAVA is equal to rand at id, and we'll multiply it by 5, and we will convert this into a integer, and we'll use this RAVA here, and that's it. So now each of our piece has some random orientation. Already it looks much better. Now we can further add more details to it, but before that, one thing we have to do is, we are not getting the p-scale attribute here. Sometimes it's all 0. So in the copy to points, we are removing the p-scale here. So we'll just remove the p-scale from here, and now we should have the p-scale attribute properly. Okay. And right now the chance is 1, so all the pieces have details. We can, okay, I forgot one thing. We need to remove the split group that we are creating. Put down a group delete node, and let's delete the split group. Now we have a detail addition, like a subnet ready. Just create another copy and connect it here, and that's it. You have new details added to it, but this time we don't need to select one. We can reduce the value like 0.25 maybe. Yeah, we have like some good amount of detail. So what this happened is, this one already selected some of the boxes and did the exact same thing again. So now if you play, we have like more detail. We have further replicated and subdivided the bots and replicated the initial animation into it. Already this looks great. Now we can add further detail if you want. So the more detail you add, it's going to get a bit heavy, but it should be fine to render like with 4 or 5 levels of detail maybe. Depends on like how much chance you select. So with 3 levels of detail, this is what I get. So this is my course called Dynamic Pedestrian System. So in this course, we'll create a pedestrian system for an entire block. So the pedestrians will like just move around the city infinitely, but following all the traffic signals. So if you like Houdini in general, or if you want to learn some Houdini crowds, I think this course is like amazing for you. Please consider purchasing it. The link is in the description.